Okay, picking it back up with number 11 here. We're still doing fractions. Fractions, we have steps. So we said, look for perfect square numbers. Talking about numbers under the radical. 2 and 3, not perfect squares. I also cannot reduce 2 over 3. So there goes step 1 and 2. I have to move to step 3, which is to rationalize the denominator. So that means get rid of the radical 3 on bottom. To do that, we multiply by a fraction, radical 3 over radical 3. That's going to make that go away. Here's how. On the bottom, the square root 3 times square root 3 is square root 9, which is just 3. So the radical just goes away, you guys, and you're left with 3. On top, I have to do that. 3 square root 2 times square root 3. You multiply the numbers out front. There's a 1 there. So it's 3 out front. Multiply the numbers underneath. 2 times 3 is 6. The last step we gave you guys was see if you can make anything better. Like if there's a fraction out front, which there is here. 3 over 3 is just 1. I can't factor tree 6. So my answer is 1 radical 6. Or you don't even have to say the 1. You could just say radical 6. All right, number 12. Now we're starting to look at some adding and subtracting. So remember from the front page that we can only add or subtract radicals if they're like radicals. The numbers are different underneath the radical. You have 45 and 5, but you always got to check to see if you can break any radicals down. And you can break down 45. 9 radical 5, that's as simplified as it gets. But look, if you rewrite square root 45, 3 comes out, 5 stays under. Okay, bring down the rest of the problem. Now I do see that I can actually subtract these because they're both radical 5s. So I'm just counting how many radical 5s there are. There's 3 here, minus 9, that's negative 6 radical 5s. That's your final answer. All right, on to number 13. So, these get a little messy. Don't we love these? Not so much. 13's not that bad though, guys. And again, the directions are just simplify, make it look better. It says distribute or FOIL, which just means like multiply it out. Just distributing, that's all we're doing. So all I gotta do is take this 3 and multiply it through. So to start, I'm gonna do 3 times 8 radical 3. You can multiply the plain numbers, that would be 24. And you can multiply radical numbers, but there's only a radical 3 there. So I kind of just bring that down. Then I distribute 3 to the second term, which is just a 7. So that's a little bit easier. Wait there. So 3 times negative 7 is negative 21. Bring that down. Always step back. Can I make it better? I cannot subtract those because this does not have a radical 3. I can't break down that 3 with the factor tree. So that is my answer. 24 radical 3 minus 21. I think that's a tough thing about all this, you guys. It's like your answer just doesn't look pretty. So we think we're not done, but we are. All right, more foiling on number 14. Start by taking the first term 2 and just distributing it through to the second group. So 2 times 6, that's just 12. Now I have to do 2 times negative 2 radical 5. I was helping someone the other day. They were really struggling when it was like distributing to the second thing. So my advice was like, write it off to the side what you're multiplying. You're doing 2 times negative 2 radical 5. I feel like if it was like this, you guys could do that. You multiply the plain numbers, you multiply radical numbers. So I don't know, see if that helps. Do like each step off to the side. It might make you see it better, like how you multiply them together. All right, now I gotta do the second little term here, 3 radical 5, I gotta multiply that through. So I need to multiply these two, plus, those are both positive. You multiply the plain numbers, so 3 and 6. Radical 5 is the only radical, so kind of just bring that down. Now I do 3 radical 5 times negative 2 radical 5. Again, if you're like, ooh, that's hard to see, do that off to the side. 3 radical 5 times negative 2 radical 5. multiplying this times this. You can multiply numbers out front. You can multiply numbers underneath. Ooh, and it would jump out at me right away. Square root 25 is just a 5. So this is really just negative 6 times 5, which is negative 30. So that kind of worked out pretty good. Negative 30 goes here. Then I want to see what can I put together. So I noticed that in the middle, I have radical 5s. So I know I can add those together. So let's put that down. Okay, so they're both radical 5s. So I have negative 4 plus 18, which is 14 radical 5s. Then I also noticed that the plain numbers on either end, those can be combined. And I'm just going to do it like it looks. 12 minus 30 is negative 18. That is my final answer. Okay, number 15. So just like we saw on the front, if something gets squared, you guys, that means you multiply it by itself. So you need to take this 3 plus 4 square root 2 and write it twice. Multiply it by itself, and then it looks really similar to number 14, where you have to distribute it all out, take it piece by piece. Distribute the 3 first. 3 times 3 is 9. 3 times 4 square root 2. Again, if that's like a struggle for you, do that off to the side. 3 times 4 square root 2. You can multiply the plain numbers, that's 12. You can multiply radical numbers. So it's 12 square root 2. That is a plus. All right, now you got to take that second term and distribute it. So that's 4 radical 2. Do 4 radical 2 times 3. Again, off to the side. Write it out if you need to. You can multiply the plain numbers and the radical numbers, but that would just stay 12 radical 2. And then you got one more term. So notice that on 14 and 15, I got 4 terms after I multiplied. You don't get 2. You forgot stuff if you did that. Just be really careful. 4 square root 2 times 4 square root 2. Okay, multiply the numbers out front. Multiply the numbers underneath. And then look at that. 4 is a perfect square. It's just 2. So the square root of 4 is plain 2. So this is really just the same thing as 16 times 2. So let's rewrite that. 16 times 2 is 32. So I'm going to write plus 32 at the end. And then I step back and I say, okay, what can I put together here? You want to make it as simplified as possible and combine stuff. So let's do blue. In the middle, just like on the last question, I could combine the middle stuff. Those are both square root 2s. Those are like terms. So I can combine those and tell you that there's 12 plus 12, 24 square root 2s. 9 and 32, those are just plain numbers. I can add those together. 9 plus 32 is 41. I cannot combine 24 square root 2 and 41, so I leave it like that. That is my best, most simplified answer. All right, 2 more. Number 16. These last 2 are Pythagorean theorem. A squared plus b squared equals c squared. And 16 is really straightforward Pythagorean theorem. Across from the right angle, that is c. That has to go by itself, you guys. 18 squared. That's a little sloppy. There we go. A and b are the other 2 sides, the 7 and the x. It does not matter which one's which. You could write this x squared plus 7 squared. It means the same thing. Okay, 7 squared is 49. 18 squared, if you put that in your calculator, that's just 18 times 18, which is 324. You need to get x squared by itself, so you're going to subtract the 49 over. So 324 minus 49 is 275. I don't know why I have to write so big. Sorry. The goal is just to find x. So if I get rid of the squared, I'm basically there, and I'm going to square root to get rid of the squared. So square root 275. I want my answer in simplest radical form. That means no decimals. I want to like put 2 radical 10 or something. I got to do a factor tree on that guy. 275. So let's break that down. If it ends in a 5, it's divisible by 5. So you could do 5 and 55. And then 55 could be 5 and 11. 11th prime. Okay, I'm ready to write my answer. Pair of 5s, 5 comes out, 11 doesn't have a pair, it stays under. This is my answer. X is 5 square root 11. Last one. You've got a rectangular pool. They gave me the picture, which is nice. And they tell me that the length of the pool, so let's bring the numbers down to the picture, is 10 yards. The width is 5. I'm going to swim from one corner to the other. Diagonally, that's my swim, the line that I just drew in. I want to figure out how far did I swim. So I'm going to call that maybe X. You use Pythagorean theorem here, you guys. Rectangles have right angles. That's a right angle. So I'm going to do a squared plus b squared equals c squared. Across from the right angle, this is c. This goes by itself. 10 squared plus 5 squared goes on the other side. Doesn't matter which order you write that in. Okay, do the exponents first. 10 squared is 100. 5 squared is 25. Okay, I'm going to add those together. So that's 125 equals x squared. And then I'm going to square root to get rid of squared. I need to write the answer 2 ways. Simplest radical form, nearest 10th. Okay, simplest radical form first. That just means simplify the radical. We do that by doing a factor tree. So let's do like 5 and 25 would multiply to be 125. And then 25 is 5 and 5. Okay, so here's my simplest radical form. Pair of 5s, 5 comes out. Another 5 doesn't have a pair, so it stays under. So in simplest radical form, this is 5 square root 5. Get rid of this. You use that simplest radical form, you guys, to get your answer rounded to the nearest 10th. You're just going to take that and multiply 5 times square root 5 in your calculator. If you need help finding the square root button, ask us for help. But when you multiply that, you get like 11.18033, blah, blah, blah. 10th is 1 decimal place. So it'd be 11 point, and it's 1/8. So that 1 is going to bump up to a 2. Ooh, that's a decimal point. Fix that. Okay, so it's 11.18. So we're going to bump it up and say 11.2 yards. That's to the nearest 10th. All right, I hope that's helpful. I hope you use this video to learn from your mistakes, correct them, so you can do better on the retake.